Namaskar, welcome back. So, this was the last slide where we were talking about the relation between the geomorphic surfaces or the indicators and the fault scarps also. Those are also geomorphic indicators. So, that is what we are calling as in terrace risers. Now, another example, but of course, we will discuss in detail when we are talking about the strike slip. This is Google image of your Karakoram fault and between Chusul and Smagmik, where we see a clear cut indication of geomorphic indicators of the faulting, which is right lateral displacement. And as I was talking about in the previous one of the slide, that you have an offset if you have a strike slip faulting. So, that also has been seen here actually. So, there is a clear cut indication, and this line here is your Karakoram fault. Okay. And further this also. Okay. So, again this fault is an important fault, and we are trying to understand that what is the role of this fault in overall tectonics of Himalayas. Okay. So, there are very clear evidence, this is from Tibetan side, very clear evidence of the offset as well as your fault scarp development, and here also we see the terrace risers, formation of terrace risers and all that. So, if we look at this part here, again we have a sort of a left lateral movement which has been shown along one of the fault in Tibet, and this is from that. Okay. So, you have a left lateral movement over here, and the figure explains that how the terrace risers will be seen, because there is an so first figure you have the movement which has been shown here. These are the symbols which talks about that the cross is the area which is moving away from us, and the circle with dot is moving towards us actually. Okay. So, in some literature you will find that there are the symbols which have been given like this. Okay. So, you have a fault here and they mark this cross, and then you have a dot here. So, that means that this portion is moving towards us and this is away from us. Okay. So, this is left lateral movement. So, what has been shown here, that you have after the formation of the surface, that is your T3, okay, which is an oldest surface, that is first surface which was formed, because how they have marked is because usually we say that as we move towards the channel. Okay. So, this is your present day stream, okay, is your present day stream. So, if you are moving towards the channel, then this surface will be younger actually. Okay. So, this is the younger surface, older and oldest, like that. Okay. So, over the time, as this fault has hosted multiple earthquakes, you will see multiple terrace risers are also displaced, and terrace risers are nothing but the terraces, the escarpment, erosional escarpments or erosional scarps develop because of the channel incision and the evolution or the process of terrace formation. There is another example which has been shown here, which talks about the displacement of, again there is a left lateral, as we have discussed, there is a left lateral here, and we can see the terrace risers which have been developed. Okay. Now, another example, if we look at this, again an important, that if you have an erosion and deposition, okay, and this we will be considering the normal faulting, then sometime, as we have discussed in one of the case of the scarp formation, then colluvial wedge, and then it's a relation with the alluvial fill, the slope and part and all that. Okay. And then residual, sometimes the residual displacement which we see on the surface could not be the same as the amount of displacement along the fault, that is in terms of the number of events. Okay. So, this part is also related to that. So, you just keep attention on this, and then we will move ahead. So, for example, we have on surface BF, and then stream is flowing towards like downslope. We have the stage 1 deposition of the BF, and then you have the erosion and partial deposition of your PF. So, this is the younger surface which has been developed. Okay. So, that we can say, let us say T1 and this is T2 or T0, T1, anything you can classify, but the number can be like increasing in as we move away from the channel and we gain the elevation. Okay. So, T1 and T0, T1 and T2 we have here, and then let us see that there is a faulting here where the right hand side block has moved up. Okay. So, what you will see in field is you will see a sort of an faulting resulted in displacement of both the surfaces BF and PF despite single event. Okay. Despite of single event, two fault scarps are formed. Okay. So, you have one fault scarp here and another fault scarp is here. So, you see two fault scarp, and then at the same time what you see is the terrace riser over here. So, this part is your terrace riser. But one thing is important which again comes from the measurement and you can infer based on that is the amount of displacement. Okay. So, the amount of displacement here, say this is if for example, this is 1 meter and this is also almost the same, okay, 1 meter. So, amount is same. So, that also helps us in inferring at the first instance that there was single event. Okay. So, this is one case where erosion is greater than deposition. Now, coming to another one. So, this is what we have final. The scarp formed by displacing BF and PF indicates that the older and younger surfaces were displaced in two individual events. This is because of the two scarps. Okay. However, since the scarp height are same, we can infer that there are this scarps are single event scarps. Okay. Now, coming to the another scenario, we can say where again the erosion is greater than deposition. The previous one is also erosion is greater than deposition, and there was single event. So, how we will see the scarp? Now, if we have another event in that area, then how we will see, okay, or another event along the same fault, then what we will see. So, again the same, you have the BF deposition, then you have faulting here, okay, and then you see a sort of an erosion here, because the stream is flowing down slope like this. Okay. So, there is an erosion here and this erosion has deposited your PF. Okay. So, let us say that this is your, so this one was your we can say the T2. Okay. So, this is T2 which has been faulted here, and we have this will be your scarp actually. So, this is your fault scarp. Now, after the erosion and the process of deposition, because the erosion is greater than deposition, okay, only this portion has been, the portion over here is eroded like this, okay, because it was elevated already. So, it eroded this portion over like this, okay. We can say that this was eroded away, this portion is eroded, Hence, we see this terrace riser. So, erosion and incision of the faulted surface and partial deposition of PF unit, leaving behind the cliffy bank. Okay, because this is not your fault scarp. This is terrace riser. Okay, and that is your erosional bank. Okay. Or you say it's a cliffy bank. Further, second event displaces. Okay, so if the second event takes place, then it will displace this whole portion along with this one over here. So fault trace goes here, and then there will be displacement here. So if you have second event, though the amount of slip is same, we are considering the same slip, amount of same slip. Okay, the BF surface shows higher scarp. Okay, so the BF surface, because it will be displaced twice, it has been displaced twice, so it will show higher scarp. So this part is your fault scarp. Okay, this is your fault scarp, and here this is your fault scarp. So PF is been displaced once, okay, whereas BF has been displaced twice. Okay. And that is the reason why BF will show you higher scarp. So elevation, we will, if we have to take the elevation, then you will definitely look at this height. So say this is 2 meter and this is showing hardly 1 meter. Okay. So what it says that though the amount of slip is same, BF shows higher fault scarp as compared to the scarp dislocating PF surface, but leaves behind the cliffy bank in the down thrown side. Okay. So it leaves behind the cliffy bank is on the side, down thrown side. So this part again we need to keep in mind when we are looking at the variable in height of the fault scarps in field, and also the variation in the terrace risers. Okay. So this was another example, like one was single event, another was multiple event. Now we say the scenario is erosion is equal to the deposition. So whatever portion is getting eroded, it is deposited, and this you can recall what we have discussed in a process of cut and fill. When we were talking about the terraces and all that. Okay. So for previous two examples also this process remains the same here. Now here we have erosion, incision and complete channel fill, because erosion is equal to the deposition. So whatever was been cut has been filled up, it has been leveled. Okay. So erosion is equal to your deposition. Now in this case we are talking about that faulting results in displacement of both the surfaces, because PF was eroded and BF was deposited, but it is leveled because the erosion is equal to deposition you are having. Okay. And result into the formation of single fault scarp here. Now one has to be careful while interpreting this, is that the faulting was after the deposition of PF and not BF. Because this will give you the timing of the event. So we see a single fault scarp which has been developed. Okay, but this was after the erosion of BF and deposition of PF where everything has been leveled at the same, because the cut and fill process has done that. Erosion is equal to deposition. Okay. So this is a single event scarp. Now same scenario we take for multiple events, how we see that. Okay. So you have the deposition, and then we say let us have a faulting after the BF. Okay. We will not wait for the erosion and deposition process. So we have an scarp which has been developed after the deposition of BF. Okay. And we have the fault scarp over here. Okay. Now there is an event of erosion. Okay. So erosion or incision of the faulted surface and complete channel fill deposition by PF unit. Then how it looks like. Okay. So this was the channel which eroded, and again this was the deposition. Okay. So deposition is equal, erosion is equal to deposition, but since there was a displacement of BF, this portion will be left out, and that is your, this is your terrace riser and this is your fault scarp. So you will see an erosional bank is left seen above the river bed, and you have also with relation to the BF transfers to the river channel. Okay. So the channel is flowing like this. Okay. So transfer to that, you have a scarp over here. Now second event, what we see is the second event displays both the surfaces. So then there will be displacement of this also. Okay. This portion will also be displaced. Okay. So whole will go up. Okay. Then what we see, that the second event displaces both the surfaces, that is BF and PF. Though the amount of slip is same, the BF surface shows higher scarp as compared to the scarp in PF surface. Okay. No cliffy bank with respect to the BF and PF. Okay. So we don't see the terrace riser on the downfaulted side, but we see the scarp or the scarp over here. Okay. Which has a greater height here, and then you have another which you see here. Okay. So this portion helps us in understanding that the process involved here, where the deposition was equal to erosion, but we had two events. Okay. Because BF scarp height, if we take from along this line. Okay. So this height is almost double than compared to the height over here. So this is the case of two events where you don't see the terrace riser in the along the downfaulted side. Okay. So we'll see one example if possible, and then we'll end this lecture and continue later. Okay. So these are the examples from the Bias River side. Okay. That is the exit of Bias in Punjab Himalaya, in the foothills of Punjab Himalaya, we can say, where we were able to see this type of terrace riser. Again, this is an anaglyph which you can see the 3D with the filter glasses, but we have generated geomorphic map of this. Okay, which suggests clearly the terrace risers over here. These are all terrace risers. Okay. This goes and further like this. Okay, these are all terrace risers we have, and then they have been faulted over here along this line. And these are two fault scarps. Okay. And even this is the terrace riser. Okay. There is a terrace riser over here. So field photograph of that. So where This photograph was taken from this side and viewing these two terraces or the terrace riser. So, next photograph if you see is from this is your left and then we go towards right here, okay, and this is what we see. Okay. So, you have a very typical profile of the terrace riser. Okay. So, this indicates that this is a scarp which has been developed because of two events, and this one is the single event scarp. Where H2 dash is higher as compared to H2. So, with this we will end here, and we will continue in the next lecture talking about the another environment on compressional tectonics, okay. And then after that we will be looking at the strike slip environment and tsunamis. Okay. So, till then take care, namaskar, thank you so much.